We got caught by
Hello,
my
everyone
boyfriend's house.
who's watching this. This is some
Anyone that's
relaxing
cool. Yeah.
stuff.
And his dad. Oh, you should probably check on his girlfriend and see if she's at school too. Okay.
Everyone, make sure to note you're being recorded.
Yeah, she voted me out. You know what the consequence was?
Everyone,
That
I'm recording you.
Oh, dang.
So you get to be seen by my dad.
No, I had to grade, so I had to.
Oh, you want to be seen.
Oh, wow.
I know. And that's why I'm making this video.
Go to a board
Yes.
thing over it. Oh, really?
That's why I have a phone, so I can...
The grading system on that is a progressive, okay? I got an A on my final exam, and that's our grade for the year. Because if you know at the end of the year, that means
Good. Don't forget I'm recording you.
Welcome to the planetarium. This is our 11 o'clock show. This is one of our live shows, our journey through the cosmos. So we are going to take a look at the nighttime sky. Then we're going to go into space, take a look at a couple planets, and then we'll see where we go from there.
Okay.
It's a 30-minute show, but you are free to leave at any point. There are 2 doors on each side that say exit. Just know the second set of doors will walk behind you. So when you get up to leave, please make sure you take all your stuff with you because you will not be able to get back in. Now, as you look up above, you might notice things do kind of move around. So
I see
if that starts to make you feel kind of dizzy, just take a break, close your eyes, and look down, and then that should help. And then one last thing, but it's very important. It does get really dark in here, and our dome is very reflective. Please no flash photography, any kind of bright lights from cell phones, tablets, light up shoes. That light will just bounce right back up onto the dome. Now, we do like to start our show by putting up the sky as it is right now. So it's 11:03 a.m. Very much daytime. So yeah, you should be able to see the sun. Yeah, clouds.
Didn't seem like it was this cloudy
And
outside.
that's
It is supposed to rain tonight.
Is it? Yeah.
Yeah, there's not a lot to see at 11.
My friend said the night
Which is why
before
we
it
are
snowed
going to go forward in time. You're gonna have a nice sunset.
Oh, there goes the sun. Dang, it doesn't go that fast.
Right.
It's probably a
We
error.
have now turned the clock forward. It is now 10 p.m. tonight. This is our sky without light pollution. So we can see a lot more stars. We can see this band of light that we call the Milky Way.
Yes.
And then this band of light is a projection problem. Don't worry about it.
Yeah, Dad. Please just ignore that band.
So for right now, we just kind of have to deal with these kind of weird blue splotches. But now that we do have a very dark sky, and again, a lot more stars, instead of just the one star, our sun, maybe we can also try to find some constellations.
Yes.
You know, some patterns in the stars.
Can you see
Are you
them,
guys familiar
Dad?
with constellations? Yeah? I believe you. Again, it's very dark. Which is why if I ask you something, you don't have to raise your hand. You can just yell it out because I will not say it. But yeah, the Big Dipper, the Little Dipper, those are ones that we're very familiar with.
Yes.
The reason why is because they are really bright and they're really easy to see. And for the most part, you can see them all year round. Although the handle of the Big Dipper does sometimes dip below the horizon. But if you are in the city and you have all that light pollution,
Dad?
the Big Dipper is probably going to be the easier one to see. And if you can find the Big Dipper, and if you follow it, it actually takes you to the North Star Polaris, which is the we got
Taking
Little
your notes.
Dipper. They're very
Yes.
famous, but they're technically not constellations. They're what we call asterisms. Asterisms are usually part of a constellation, the part that's really bright, easy to find. So they're great for navigation. Although sometimes they can kind of make up their own shape. But in the case of the Big Dipper, it is part of this constellation right here that we know as Ursa Major. It's our
Bear.
Big Bear constellation. Ursa meaning bear,
Remember
like
that
Teddy
the
Ursa, and then Major, our Big Bear.
Dipper was part of it.
And then the Little Dipper, it actually is a constellation by itself, and it goes by the name of Ursa Minor, which is our little bear, even though it doesn't look like a bear. So they both have these tails that bears don't have. And it really does have to do with the story behind these constellations. Kind of, basically. So yeah, most of our northern constellations are adopted from the Greek constellations. So they have that mythology tied in with them. And Ursa Major is a woman named Callisto. She also has a moon named after her. And Ursa Minor is her son Arcus. They were both turned into bears by the god Zeus. And for their protection from the goddess Hera, he placed them into the nighttime sky. Just not very gently. He took them by their tails and just kind of swung them up into the sky. And when he did, he stretched out their tails. And that's why they look that way. Now, another really famous asterism you might have heard of can be found all the way over here. These three stars. Do you know what that is? So it is
It's
a belt.
Orion's belt.
Orion, yeah. So that is Orion's belt. So those are very bright stars. And once you find them, it does make it easier to find the rest of him. So then now we have a torso, we got some arms. Up for interpretation. So that is the Hunter Orion. And there's different artworks. Some fit better than others. Some constellations, just in general, need a little bit more imagination. So he fought a giant scorpions. And after their battle, they were both placed into the sky, but never at the same time, because they do not like each other. So Scorpius is a summer constellation, while Orion here is more of a winter constellation. So that's why he's a little bit low right now as we're going into spring. But if we were to actually go forward in time, you can see that Orion is now starting to set. And as he starts to set, that is when Scorpius starts to rise in the sky. Interpretation. Again, he also has an asterism known as the fish hook. You're familiar with Moana? So the fish hook is just this part. And so if I stop the clock again now, we're at almost 5 in the morning. So not the best time to see him. If you want to see him at a more reasonable hour, wait till like June and July. Because then it'll be more like at like 10 o'clock, he'll be like way up here instead of having to get up at like 5 in the morning. So yeah, that's why most constellations are going to be seasonal. There's better times to see them. So again, these are the constellations you'll see at like 5. But if we went back in time to a more reasonable hour, you can see that all the constellations are moving. It's not because the sky is moving though, it's because our planet is always in motion. As we turn our axis and also just go around the Earth. Sorry, the Earth goes around the sun. There we go. So also have Draco the dragon. Yeah, the Hydra right here. So it's a serpent that if you cut off its head, more grow in its place.
They
Yeah,
have
like
a lot of
Hercules.
names I can't even
Although
say.
it's actually not Hercules that fought the Hydra, it was Perseus, I believe. Hercules and Perseus are kind of combined in Disney Hercules. They're both sons of Zeus, very famous warriors. Perseus is actually right over here. Hercules was in the sky. The Percy Jackson books are rooted in mythology, so yeah. But yeah, again, they're both very famous Greek heroes. And so Disney, like Disney likes to do, kind of just took both of them and combined them together to make one hero.
She's gifted in that, is she? She's very smart.
So yeah, again, most of our northern constellations are from Greek mythology. So the Greeks were one of those civilizations that used the sky to map out for navigation. But there's also different cultures as well. So a lot of Egyptian constellations and even Native Americans have their own set of constellations as well. Yeah, no, we could definitely spend an entire show just learning more about our nighttime sky. But we're actually going to move on to the second part of our show, and we're going to start our journey into space. In 5,
Did you hear that, Dad?
4, 3,
No, when we're in
2,
the car instead of.
and 1.
Yeah.
So does James.
We've been on Earth this entire time, guys.
And now we're in the sky. We're going into the sky.
Yes, that's Earth.
That's Earth.
Yeah, it's the Earth, and it's all of our city lights. And actually, if we were to turn the constellations back on, the sky would look even different. This one right here? Yeah. So that is Thetis. She is a giant sea monster that Perseus fought to save the princess Andromeda. Princess Andromeda. She is a very famous constellation. She has a galaxy right next to her,
Yes,
the Andromeda
Scorpius.
Galaxy.
Yeah, well, it's
Yeah, you know, it's a
since
really like kind of
in the
smudge
sky,
in our sky.
it's upside down now. Yeah, it's upside
This
down
is also
now.
a snake, that serpent. It wraps around Ophiuchus, the snake charmer. So he's another constellation. He's technically the 13th zodiac that we don't talk about. So the zodiac are zodiacal constellations like Scorpius and Sagittarius. They're all on this line right here, which we call the ecliptic. And he technically counts because his foot touches the ecliptic. Yeah. So yeah, let's see. Cancer would have been the other way. It's fine. So yeah, we got Virgo. She is a very big constellation. She takes up most of the ecliptic. And then we have Cancer, yeah. So Cancer is between August and July. Right over here. Pisces would be closer to March. Yeah, so if we look and we try to find our sun,
Gemini.
we need to get to March. So yeah, we got May, and we're at April, and as we make our way, and we look for the beginning of March, is where you'll see our sun.
I know, I'm a Gemini.
Because we are at, yeah, we are
right
at
on the
March
cusp
6th.
of Gemini.
So that's where it lies on the ecliptic. So the Earth moves, everything moves, even the sun moves a little bit too.
Yes.
It wobbles on its axis, and everything in our Milky Way galaxy is technically also moving. We're moving around our galactic center, just very, very slowly.
Plus, fun fact, the black hole at the center of our galaxy's name is Sagittarius A.
Yeah, so Sagittarius A star is our supermassive black hole. Again, at
in the center of our galaxy.
Of our Milky Way galaxy.
In the center?
Yes.
But we are still very much in our solar system. We have not gotten very far. So before we head out into deep space, which we can do, are there any other planets you would like to see?
Mars.
Okay.
No, Mars.
Okay. So those are some great suggestions.
I want to see Mars.
She heard you say it. She's got to decide what she's going to go to.
Mars.
She heard you.
Sup,
Yeah,
Mars?
so we're at Mars.
See?
Yeah, we're at Mars right now. It's the red one. Why does it look like what? When you're on top of it, like if you were to land on it. I mean, we can zoom in or we can land.
Land.
You want to land?
Because I think that would be
Okay.
cooler.
Give me a second.
Yeah, I want you to land in the trench. What is that called again?
If we want to land and actually see something, we kind of have to go where there's some elevation, either high up or a lot lower. We're actually going to go lower because you see this like right here.
Yes.
So that is called Valles Marineris,
Oh, yeah.
and it is the largest canyon system. So think of kind of like the Grand Canyon,
But way bigger.
much bigger.
Like,
it can stretch across North America from coast to coast.
it's the Olympus Mons of canyons.
Yeah, and Valles Marineris is also out colorized. Oh, hold on. The imagery. There we go. Land in Valles Marineris. So I have now switched it to an actual elevation map. So we can get some really cool detail of this canyon system.
Yep.
Now it's almost getting too close.
So on average, yeah, it's about 5 miles deep.
Yes.
5 miles.
Yes.
Yeah, that's pretty deep.
Yeah.
Grand Canyon's pretty deep. I don't think it's that deep though.
Yeah, but Valles I don't really. I think Valles Marineris is much of a more cool of a canyon.
Yeah, when you said that one, the cooler was more accurate.
So yeah, we are now in the
More
canyon
cooler.
system. Yeah, and if you look up into the sky, it's really dusty. So yeah, the thing about Mars is it's kind of like a desert, just a really cold desert. So most of its weather is basically sandstorms.
Structure and stuff. When do they start teaching
Yes.
that in school?
I think he's learning that stuff.
Is he learning that stuff?
And so yeah, it kind of went
Punctuation and
forward in time,
yeah.
kind of the nighttime.
I think that place actually has a
You can
blue
actually see the Milky Way and the
sunrise.
stars really well because Mars does have an
Are we on
atmosphere.
it
It's
now?
just really thin.
Yeah, I think
Most of
we're
the
on
beautiful
Mars.
pictures.
In the Valles Marineris.
But that's not snow.
Yeah, you would still need a spacesuit. There is not a substantial atmosphere. There we go.
That's Venus.
Venus has clouds of sulfuric acid.
I think we should look at that one next.
But we're now going to let's go back into orbit. Well, you definitely could not land on Jupiter even if you wanted to. So the inner planets, like Mars, are rocky bodies, what we call terrestrial planets. So again, there's canyons, there's volcanoes.
There's even
That one right there, that's Olympus Mons.
yes, the largest. Like I think
it
it's
is the largest volcano in our solar system.
Yes,
So yeah, even
even
though Mars is a much smaller planet, roughly about half the size of Earth. It does have
Phobos
some
and
great
Deimos.
features, and it does have 2 moons, Phobos and Deimos.
Yes.
All right, but yeah, let's go take a look at a different planet.
Venus. Venus. No,
You already got to look at Mars. The other kids look at one now.
mostly made up of hydrogen and helium gas. The atmospheric pressure would eventually crush any kind of spacecraft that tried to go through it.
Oh, is that the reason why I know it full of stuff towards? Is that why we get asteroids and stuff?
Well, asteroids are just everywhere. They're in the asteroid belt, but they're also just kind of are just everywhere.
Yeah.
And if they get too close to a planet, the planet's gravity can pull that asteroid in. Which is probably also why planets like Jupiter and Saturn have so many moons, because they're really massive and they can host all of that stuff. Currently, Jupiter has 95. That's how many we've found so far. Now,
Yes.
the thing about Jupiter
I see
is
Europa.
that it's a really stormy planet. Most of its heat is internal, and so you kind of have this banding that goes across it. The darker band is that warmer air at lower altitude, and then the lighter
That's what it
band
looks
is
like.
that
Here's some
cooler
numbers,
air at the higher altitude.
Yes,
Whenever
they're
you have
using
any kind
numbers
of
for some.
turbulence, when a warm front
I
meets a
know.
cold front, you get these really crazy tornado, hurricane-like storms. So anything that looks like a circle.
Yeah. But
And
I
because
think
of Jupiter's rotation, they're very continuous storms. We've been studying the Great Red Spot for over 200 years. So yeah, this is Jupiter's largest storm.
see
It
that?
is somewhere on the planet.
I'm talking to the phone.
Right over here, yeah. Yeah, so it sometimes changes in color. It actually has kind of shrunk in size. It's a little bit more circular, where it was a lot more elongated a while back ago. But it does show no signs of going away anytime soon. All right, but I know we have a lot we want to go see, so we're going to move on.
I want to go to Venus. No, Venus.
Nope. So, welcome to Uranus, named after the sky god Uranus. It's the only planet to have a Greek name instead of the Roman. But that's not the only thing that makes Uranus unique. The biggest thing is the fact that it is completely tilted on its side.
Yes.
Which you can see with the rings as they go up and down and step across.
I know.
Yeah, so all the outer planets have rings. Jupiter, Saturn, Uranus, and Neptune.
And I think Mars will have some in a couple 100 years. Because I think Mars will have some rings as well soon.
Also cannot land here either.
Because it's a gas giant.
So it's kind of like a gas giant. It's mostly hydrogen and helium. But our outer planets, the furthest ones, Uranus and Neptune, they're a lot colder. And in their mantle, they're really icy. They have a lot of water vapor, ammonia, methane, and
Stuff
so
like
instead we
that.
call them ice giants. But not solid. Not solid ice. Think of it kind of like a slush. A very slushy mantle, and then like a solid core. Now, Uranus obviously does not have as many moons. It is smaller than Jupiter and Saturn. We have found 27, and they're very British. So instead of being named from mythology, they're named after Alexander Pope and Shakespearean characters.
Titania. Cupid. Oh, I see Ariel.
I know what Jeff's.
So
No,
this is a different
Robin
Ariel.
wanted to
This
name her
is from
daughter
a work
Ariel,
from
right?
Alexander Pope.
He wanted
Although
her
most of them
because
are
they
Shakespeare.
said that was her sister name.
Because Uranus
Oh,
is named after a sky god, a lot of the first moons have to do with light.
Come up with
So
that.
a lot of them were named after like
Yeah, I
fairies,
don't know.
like Oberon and Titania from A Midsummer's Night's Dream.
I've never known her name was Ariel.
So yeah, because the thing about Uranus and Neptune and Pluto and everything else that is much further away is that it took a while to discover them. So you can't really see Uranus in the sky with just your eyes like you can with the planets that are closer. So Uranus
Hey, at
wasn't
least these
discovered
ones
until
look
the
easier
1700s.
Say. Yeah.
Yeah, basically we needed to invent telescopes and stuff.
I could
Plus,
use most of those.
By the way, there might be a planet 9 doing something with Neptune's orbit.
Well, that's how we found Neptune in the first place. Is
Yes.
We found Uranus, and then we're like, Uranus isn't acting the way it should. Maybe
So
there's something else out there, like affecting its orbit. Maybe there's another planet.
Like
And
Neptune.
It was Neptune.
No. I
Uranus
think
and Neptune
that's-
are both blue, whereas Venus here is the yellow one.
Yes, Venus.
Yellow because of sulfur.
Yes. Plus, by the way, that place has acid rain
So,
and lots of CO2.
Its atmosphere is mostly CO2. Very thick. You can't even see the surface. And it's really great at keeping heat in, which is why its surface stays around almost 900 degrees Fahrenheit.
Yes. It's the hottest planet in the solar system. Hotter than Mercury.
So even though technically you could try to land here, you shouldn't. Robots either burn up in the atmosphere or are eventually crushed by the atmospheric pressure, which is about 90 times
Tell
that
an
of Earth.
astronaut to eat more than cheese pizza.
And if you were to strip away this atmosphere, you would
Eat
see
more than cheese pizza.
that it's pretty much a lava world.
Yes.
So unlike Mars, Mars has volcanoes, but they are dormant at the moment.
His
Mars
taste
is pretty
palette
much
could
kind of
change
in
by
an
the time
ice
he
age.
gets to be an adult.
Whereas Venus is still very volcanically active. So yeah, it's known as Earth's twin sister, mostly because we're
I
about
don't
the same
think we're going
size.
to be here, but
And
we're
mass.
supposed to live like we are.
Opposite.
It
Yes.
doesn't mean we quit learning and doing things.
So yeah, there's a
because
reason why people want to try to get to Mars, and nobody wants to go to Venus.
that one was kind of pretty, though.
I know Venus actually is a really pretty planet.
So we are kind of running out of time. I know we've seen a lot of really cool stuff. Really want to see Pluto. I have a size comparison thing.
You want to be an astronaut?
That
Yes.
makes you feel really small about yourself.
That means you're going to have to go to school for a long time.
I know.
So it's not everything,
like
but it's a
school?
pretty good thing.
Yes.
Like a
school
pretty good
itself, just
amount.
not some of the kids, huh?
The first one
Yeah.
is a dwarf planet and moon size comparison. So we're looking at some stuff that's a little bit
That one
smaller.
was pretty cool.
I know that's Earth, I think.
Yeah, so comparing it all to Earth. So that's our moon,
The moon.
and that's Pluto.
Pluto.
And it's largest moon.
We only have one moon, and those
Sirius
other
is
ones
the
have all.
smallest dwarf planet. Then we got Haumea. Haumea looks like me.
But one had to with
Then we got
95
Monkey
moons.
Monkey and Eris.
Yes.
How come we only
So
have one
those
moon?
are all of our dwarf planets.
And those other ones have a whole lot of moons.
I know. That's.
But then we're gonna look
God.
at some moons.
Next
This is
time,
Phobos
can
and
you give
Deimos.
us more
Those are the two
moons?
of Mars.
Phobos and Deimos, the two rocks.
Yep, they're very tiny.
What?
I called Phobos and
Then we have
Deimos
the Galileans
two
of
rocks.
Jupiter.
Rocks?
Yes. Those are
And here's
my
a couple of
favorite
Saturns.
moons.
A couple of Uranuses, and then Triton is the largest moon of Neptune. Yeah, it's not all the moons that take up the entire dome, but these are some of the larger moons that are out there. All right, but now we have our planets. So we all know Mercury is our smallest.
Mercury.
Then we got Mars.
Mars, second smallest.
Then we got Venus.
Venus, third
That we
smallest.
just saw.
We got see
And
Earth.
then here's Jupiter again, our largest.
Yes. Home of my favorite moons.
And then there's Saturn. And then Uranus. Then Neptune.
Plus,
Well, then yeah, the last thing in our comparison is our star.
yes, which is so unbelievably large. Like,
Yeah, because you can fit like a million Earths inside.
yes.
the sun.
Like, you can. Not a billion.
About a million. Or you could fit like 1,000 Jupiters.
Yes.
Okay, so we're gonna do one more thing, and then we have to end the show.
Sadly. I
Those
think
Earth
they
right
are.
there.
Would you like it? Looks like snow.
No, it doesn't. It looks like milk drops, which is why the
Well,
galaxy is
that's what
called
snow
the
looks
Milky
like.
Way.
That's what snow looks like, milk drops.
Ton 618.
So we're actually going to take a look at our supermassive black holes.
Sagittarius A.
Sagittarius A. And while it is still pretty big, there's definitely a lot of other supermassive black holes in other galaxies that are much larger, more massive.
Like Ton 618.
Now, luckily, we are far away from our supermassive black holes. We're about 2/3 of the way in one of those inner arms. So about 27,000 light years away from our galactic center. So we're good. Now, it's called Sagittarius A star because we love to name things after constellations. So it can be found in the direction of Sagittarius. And so you might notice, this entire center is really, really bright. And that is
Yes.
because that's where the bulk of our stars are, is in the center. Whereas the spiral arms is where you're going to find more of like the newer stars and a lot of that gas.
And the ones with life.
Star forming region.
What?
Also stars with planets
down
with
the
life.
I wanted to, I go, woo! But I didn't. I lowered it down.
Wow, those are a lot of stars.
So this is actually a cluster of stars called the S stars. S for Sagittarius. And they actually orbit around our supermassive black hole. And so it's by studying these stars and how they seem to move around an unknown object that became the first observational evidence that our supermassive black hole existed. So because you cannot see black holes directly, you kind of have to observe them indirectly, how other objects interact with them. But if we were to go towards the center of this cluster,
Oh, there's Sagittarius A.
this is Sagittarius A star. It is about 4 million times the mass of our sun.
That's true.
So in our solar system, the sun is the most massive object, and that's why we do go around the sun. But things that have mass have gravity. The more massive you are, the stronger your gravitational pull is, and things start to get pulled in. So like our solar system, these stars can go around this black hole and be perfectly fine, just as long as they're at that safe enough distance. But things that do get too close to get pulled in, to escape it, you would have to go faster than the speed of light.
Yes. That's why it appears so black and like
Making of
nothing.
a supernova? We do have a supernova thing, yeah. Because so these are supermassive black holes. You might be, which are probably what you're more familiar with. Whereas actually the most common types of black holes are actually what we call stellar mass black holes. And they are created when very, very massive stars, stars much larger than the sun, reach the end of their life. This has a flash. Close your eyes. Close your eyes now. So that star became very unstable towards its end, where it couldn't make any more energy. So it couldn't support its size. And so in the end, it collapsed.
Hello,
And then
stellar
it
black
rebounded,
hole.
and then it exploded. And that's what we call a supermassive black. That's what we call a supernova. And if a star is massive enough that in that collapse, it collapses completely past its core, that is what forms a stellar mass black hole.
She said it collapsed. What does that mean?
Now, other than just observing stars,
I don't know how to
as you've seen with
explain
both
it.
of these black holes, they have these
But
massive
yes.
disks around them. These disks are made up of gas and dust, just swirling
called accretion discs.
Accretion discs, yeah. And in the meantime, they are creating a lot of friction, which is creating a lot of energy and radiation that we can pick up on. So it can be a little bit harder in the smaller black holes, but using radio telescopes from around the world, we created what is known as the Event Horizon Telescope. The Event Horizon is basically the point of no return for a black hole. And so these telescopes basically created an Earth-sized telescope. And by pointing them at a supermassive black hole, they were able to map out the accretion disk surrounding it. So this image right here came out in 2019. That is of a supermassive black hole in a galaxy called M87. Later, they added more telescopes to the array and pointed those array of telescopes at our galactic center. And at the end of 2022, they released this image of Sagittarius A star. All right, so we have definitely had gone way over, but we have now returned home.
That's
and are going
good.
to land right back at the museum.
I'm glad she didn't leave us out in space. I did, so. I'll show you here. No, you don't.
What is this romantic music?
Yeah. So that must be very hot-blooded.
Dad, I'm sorry that appears purple. It's actually a light blue. Rainbow. I see rainbow. And yes, I recorded this entire show.
Okay.
So my dad can see it. And I was pointing my phone at all the stuff.
Astronomy, planetariums are great for that.
Yes.
Or you could be an astrophysics if you really like math. Or an astronaut, yeah.
Yes.
Boy, that's a lot. I think a lot of schooling for that.
A lot of schooling. A lot of astronauts also tend to be people who are, especially in the beginning. Most of the astronauts in the beginning of the space race were jet fighter pilots. Which is actually why so many yeah, and so that's kind of like who they hired for that. People who are, yeah, so a lot of people who are the beginners.
Time for lunch?
Just about. Let's go over to the
That focused on it.
Yeah. It's great. Space is fun, and there's always so much more to learn, and we're always learning stuff.
Yes. I might help discover new stuff.
So yeah, if you're really into like wanting to like discover things, then yeah, trying to be like an astronomer or an astrophysics, people who look at the data and try to find like exoplanets is a really big field right now.
I know. Like, I think there's a couple thousand exoplanets we know
we're
of.
over 5,000 now, and we're just always finding more. That's
Yes.
a really big study right now.
All right, let's go.
Didn't know you knew all that stuff. Either way.
Oh, something on the ground.
Oh, so yeah, that's our power supply bank. So there's like outlines right there.
Oh,
It looked like a piece of paper, didn't it?
yes.
Yeah, see, Thor, she helps you do that. Those are really fun.
You could try to ride it.
Try and ride what?